Let's see more comments. Git status helps you track of which changes have been added or not. So on what branch you are on. So and git status lists the modified files in the workspace as well as the files in the index. So let's check the git status. I'll put it this side now. I'll clear the screen and I'll say git status. See, now we are on master branch, on branch master, and in this at this moment nothing to commit. So working tree clean, so there is nothing to commit, we haven't added anything. So now we will add one file in that. So ls I will add this time a python shell script. So touch script.sh. See, now we'll give the git status. Now you see untracked file. How many untracked file we have in this? We have one untracked file, that is script.sh. That's what it's saying. So what we have to do to track this file, you have to use git add and then file name. So git add and it's script.sh. Now let's give the git status again. So now on master branch, we are on master branch, changes to be committed. So the file has been added to the index, or staging area. Now you have to commit this change. Now you have to commit these changes. These changes. So I would say git commit m option, and I say it is committing shell script. So commit has been done. You see that master branch and then short unique id of this of that snapshot, and committing shell script is the message, and how many files added, one file changed, and 0 insertions and 0 deletions. So this is in create mode. So now we'll give git status. So at this moment again nothing to commit, working tree clean. So what it does is it will check, is there any new files have been created in your directory. If it is created, if it is not added, if it is not committed, that it's going to show. That's what the git status says. It will make sure that every file is under tracking. So then we have git log. So git log shows the history of the changes, that is commits in the working directory or with the or just mentioning git log and then path the changes applied to the given path. So let's look into the git log now. So I'd say git log and then graph, decorate the graph. Without that also you can get it, but I want a decorated graph. See here, nicely decorated graph, we got it. So how many commits we have made so far? If you remember, we have done only two commits. The first commit, just please, let me make it slightly bigger. Yeah, this is commit A, and then this is commit ID, snapshot ID, and then from, so head, this is head. Head is referencing to whom? Master branch. So of course at this moment we have only one branch, so that is master branch. So head is referencing to the master branch at this moment. If we are in another branch, that time head is going to reference. Here it's simple. So this commit is done in this branch. That's what it says, nothing else. The head says this commit has been done in the master branch. So then this is other and date information. And what is the commit message? Committing shell script. This is the recent one. Then another commit. So this one is also same, head and master. So that's the reason both were put in same line, you see, same line, then with the same indentation. Then this is the previous commit, this is the commit message to understand the functioning commit. Okay, this is the previous commit. Now you can see that you can get the number of commits that we have made so far using git log. Then we have, you can look at the differences between files with the git diff command. Just using git diff without parameter only shows the changes in the working directory that have not yet been added to the index. So let me clear the screen and add Python scripts now. Okay, touch module 1 2 dot py. So I have I think 2 Python modules. So now let me do git diff and see what's going to happen. So nothing had happened, it hasn't shown any differences. But if you want to use this git diff command, so you need to add your parameter. That could be basically if you have another branch. So now we have only one branch. Once we create the branch, that time we will use this git diff and find the differences between this branch and then master branch. Okay, so let's do that in next slide, not now. Okay, so git diff, and then if you give the name here or path, that shows the difference between the current working directory and the named commit of the working directory of the given path respectively. The name can be a commit ID or a branch name or another name. So anyway, branch name we are going to do in next slide. So here we will be doing with only commit ID. So this is good time to do this exercise. Okay, anyway, let me give the git status so that I can get nope, nope. I'll give git log and then I say graph, then decorate that graph, then I say all. Let's here it is. So where is my, yeah, I'll take first 5, that's enough. Copy this, then clear the screen, git diff, and then paste it. Let's see what's going to happen. Nothing had happened. There is no much of difference between that command and that what do you call that commit and then master branch. So this time I'm going to give the complete okay, anyway, we are going to see this git diff in our next slide. So let me clear the screen off now. So due to the length of commits IDs, those are called commit IDs. So git log, yeah, you see that very big commit ID, this much. You can see that it's a huge. So because of the length of this commit IDs, we only use abbreviations like A, B, and so on in this diagrams, in this pictorial representation. Okay, so if you look at this example, the naming of things in git, so snapshots are the main elements in git. As we know, they are named absolutely with the commit id. You see the commit id here, it is, so which is a hash id like 8D23CADF751, etc. So for example, it is derived from the content of the snapshot, which comprises of the actual content and some metadata like time submission or other information and parents, etc. This is what the meaning of a commit ID. It's not just simply made, so it consists of an information about the actual content and some metadata like time of submission, other information and parents, etc. So now git can, let's say, okay, we are saying the naming convention. Then git can actually, for convenience, it abbreviate the long hashes to short names by taking the minimum number of characters from the start of the ID so that the short name is still unique within the repository. So in this example, instead of going for the here in this example, instead of going for the long hash ID, you can select the first four characters out of it, and then we can use it. We can use it in our in our commands. And note that the term commit is used both as verb for creating a snapshot and as a name for the resulting snapshot. Normally, you do not have to work with the commit IDs. Instead, you work with branches. A named a named stream of changes in other source code repositories is called a branch. In Git, a stream of changes is an ordered list of change sets as they are applied one after another to go from one snapshot to the next. So simply to put, is a branch in Git is only a named pointer to a specific snapshot. That's it. It notes the place where a new changes should be applied to when this branch is used. When a change is applied to a branch, then also the branch label moves to the new commit. So how does Git know where to put the change from a workspace? So that's where the head points. That's where the head points. The head of the development is where you last checked out of your workspace. And more importantly, where to commit the changes, it usually points to the branch you last checked out. So note that note that this is the different from a CVS interpretation of the term head as the tip of the development of the default branch. So then how does Git know where to put the change from a workspace? So that's basically depends upon the head point. I'll show you that head point. 1 minute. So let me clear the screen first and enter into the Git. You see here, you can see the head clearly. This is the head I'm talking about. So cat head. Now at this moment it's referring to heads in, and it's referring to the master. So now whatever commit that I do, that commit will be attached to the master branch only. If you are in a different branch, if you checked out to the different branch and if you commit there, then the head will point to the that branch. Anyway, we'll be doing that. Okay, so now we'll look into the tag command. The tag command names a commit and allows you to address the individual commit with a readable name. Basically, a tag is an alias for a commit ID, but commits can also be addressed with some shortcuts. So head as the tip of development in the working directory. So then we have a reflog. A reflog shows what has been changed during the lifetime of the name from when it was created, usually by a branch, until the current state.